Viruses aren't alive. They don't have cells or the ability to reproduce on their own. But these microscopic invaders know how to make themselves at home in your body. And that's why we keep getting sick. So here's how they work. It all starts when an infected person sneezes, coughs, or talks. That releases virus particles into the air. These particles are so tiny, you need a microscope to see them. Some viruses float around in the air for hours, waiting to find a new host. Others drop to the ground quickly, where they wait for someone to pick them up by touching a surface or by putting their hands in their mouth. Either way, once a virus particle finds its way into your body, it has to find a cell to infect before your immune system can kill it. Your body is full of different kinds of cells that a virus could target, but each one has a slightly different door that the virus has to open. For example, influenza, the virus that causes the flu, targets cells in your respiratory system. Specifically, it latches onto sialic acid molecules on the surface of epithelial cells lining your nose and throat. When the virus finds the right kind of cell, it binds to it, then injects its genetic material into the cell. Once inside, the virus sheds its coat and leaves behind its DNA, or RNA. This hijacks the cell's machinery and turns it toward making more viruses instead of doing its normal job. The new viruses leave the cell and infect others, causing more cells to turn into virus factories. That's how viruses work. They invade your cells, change what they do, and multiply until your body gets overwhelmed. But there's more to their sneaky ways than that. See, the virus needs to get into your cells to survive, but that doesn't mean it wants to destroy them.
Ow.
If the virus kills the cell too quickly, it won't have enough time to replicate and spread. So instead, it goes into hiding, disguises itself as part of the cell, and lies low until the right conditions are in place for it to start multiplying. For example, HIV, the virus that causes AIDS, has a special enzyme called reverse transcriptase that lets it make DNA out of its RNA. This DNA hides in certain white blood cells, which are supposed to protect your body from infection, and stays quiet for years. Meanwhile, this hidden viral DNA can be passed down every time the infected cell divides, like a sleeper agent waiting for its moment to strike. Other viruses are more direct about taking over. When they infect a cell, they start turning it into a virus factory immediately. For example, when you get a cold, rhinoviruses set up shop in the cells lining your nasal passages. They use your cell's protein synthesis machinery to make copies of themselves and break down the mucus so they can spread. And because your immune system is focused on fighting off the initial infection, these viruses often have a chance to infect more cells before they're noticed. And that's why colds are so contagious. Once your immune system does catch on, though, it sends out killer T cells to identify and destroy infected cells. They recognize infected cells by looking for a protein called MHC1 on their surfaces. All nucleated cells in your body normally display MHC1 molecules, which are like ID badges that say, "Hey, I'm a normal, healthy cell." But when a virus infects a cell, it takes over the cell's machinery and changes what it's making. The new viral proteins can end up on the cell surface, and the immune system will see that as a sign of distress. So the infected cell displays the viral proteins on its MHC1 molecules and presents them to the killer T cells. The T cells recognize these abnormal ID badges and destroy the infected cells, ending the threat that they pose. But some viruses have evolved ways to hide from this surveillance system. For example, viruses like herpes simplex, which causes cold sores, suppress the production of MHC1 molecules. Without those ID badges, infected cells can't alert the immune system, and the virus has a chance to multiply without being detected. When viruses take over a cell, they can also mess with other parts of your immune system. For example, when you get the flu, influenza viruses infect cells in your respiratory system and start making copies of themselves. As they take over more cells, they release chemicals that cause inflammation. Your body does this as a defense mechanism to try and keep the infection localized and prevent it from spreading. But the symptoms that come along with it, like a fever, weakness, and muscle aches, just make you feel miserable. And since the virus has taken over so many cells, it's able to evade your immune system long enough to spread throughout your whole body. As it spreads, it uses up resources and makes more copies of itself, which can cause even more problems. For example, when a pregnant woman gets the flu, the virus can cross the placenta and infect the fetus. Then it can cause miscarriage, stillbirth, or premature labor. And if the baby survives, it might have breathing problems or other serious issues. That's why it's so important for pregnant people to get the flu shot. The damage caused by inflammation can also affect your immune response to the virus. For example, in severe cases of dengue fever, the virus kills so many cells that it overwhelms the body's ability to produce platelets. Platelets are important for blood clotting, so when they're gone, bleeding becomes harder to control. That's one reason why some people with dengue fever have such high fevers. Their bodies are trying to make more platelets to compensate. But inflammation isn't the only way that viruses cause disease. Some viruses directly attack specific organs or tissues. For example, polioviruses travel to the central nervous system and infect motor neurons. Then they stop the nerves from sending signals, which can cause paralysis. In severe cases, that might affect muscles needed for breathing, leading to death. That's why it was so important to get the polio vaccine. But not all viral infections cause such dramatic symptoms. Some viruses cause no symptoms at all. We call these latent viral infections because the virus remains in the body without harming it. For example, after chickenpox, the virus stays in nerve cells and can reactivate later in life as shingles. Even when viruses cause mild or no symptoms, they can still be dangerous. For example, hepatitis B is a virus that attacks the liver. Most people clear the infection without any lasting effects, but some develop chronic infections that can lead to cirrhosis, where scar tissue replaces healthy liver tissue. Cirrhosis raises your risk of developing liver cancer, which is why scientists are working on a cure for hepatitis B. And even though viruses evolve all the time, they have to follow the rules of nature. For example, they need to stay moist to survive. That's why some viruses prefer colder climates or are spread by insects that live in warm places. Knowing these rules helps scientists track and predict outbreaks, which is key to stopping viruses in their tracks. So viruses can be sneaky and they can be deadly, but understanding how they work gives us the power to fight back. Vaccines work by exposing our bodies to weakened or inactive viruses, so that our immune systems can learn to recognize them and fight them off. Antiviral drugs work by targeting specific parts of the virus, like the enzyme that HIV uses to make DNA. And public health measures like quarantine and social distancing can slow the spread of infectious diseases, giving us time to develop treatments. If we keep learning more about viruses, we'll be able to stop them from hijacking our cells and wreaking havoc on our bodies. And that's a future worth living for. At Minute Earth, we love digging into the data. Whether it's analyzing the spread of misinformation or understanding the effectiveness of different teaching methods. Data is everywhere, and it can help us solve big problems. That's why we're excited to partner with Brilliant, whose mission is to help people learn math and science interactively. Brilliant uses fun and engaging puzzles and lessons to help you learn something new. And right now you can take their Brilliant course, Data Analysis with Python, free for 30 days. That's a great opportunity to explore data for yourself and see what all you can discover.